So next, let me give you sort of a feel of the differences between these complex and complicated contexts. And I must say at first, because there's no problem that always falls into one of these facets or domains. And you also might remember that in the end of the sense-making section, I introduced the Cynefin framework. So these are two of the those domains, but we will stick to this because it's simpler and enough for the purposes that we have now. So we have each problem, each facet of a problem, we can place it somewhere in this continuum. And we'll first talk about system characteristics. So in the complex context, the system is sort of interdependent and operating via this interaction dominant causality, whereas in the complicated context, it's the components are isolated, and we can solve them, as I just said, by decomposing the system and solving for each sub-problem separately. In complex context, there are a lot of unknowns. We don't know necessarily what we don't know. Whereas in the complicated context, we know what we don't know, and or we actually know what to do, and so it's less of a mysterious place to be in. And hence we have the unpredictability versus predictability dichotomy. And said the complex in the complex systems and complex contexts of problems, the components are changing and adapting and moving and learning. Whereas in the complicated domain, they are sort of they stay the same. They are quite rigid, inflexible. They are what they are. And this sort of gives us the stability that we can work with those problems with what we have learned before. And then when we move to these problem-solving approaches, in complex context, we need innovation and new learning, whereas in complicated contexts, as I just said, we have this tried and true practices. So we don't need to do that much trial and error. So we do this experimentation and exploration and all this work we do when we're dealing with a complex context, whereas in complicated context, it's usually enough for us to actually analyze the data that we have, and so that we can come up with good solutions with predictable results. And this is a metaphor by Tom Kervin. So he made this distinction between sowing seed and analyzing the soil. So if you're a gardener, you sort of have two caricature approaches to working your garden. So one person might be bound to just sow the seeds and throw the seeds in the garden and see what kinds of things come up, and then try to control the weeds and then foster the nice plants that are growing from the seeds that were sown. Whereas in a complicated context, you could have another gardener who would make really deep analysis of the soil and look at, okay, so which plants could grow here and be very well-being and so forth, and in that way choose like the places where to put the seeds and so forth. And so I said these complex contexts usually need this trial and error behavior, whereas in the complicated context, you can just analyze and then go and implement. do what your analysis said was the best thing, and you can expect it to work. And we also spoke about this decomposition-based design that works when you're in a component dominant system. So breaking the problems, decomposing issues and problems into their component parts, solving each part, and moving on. Whereas in a complex context, you need this evolutionary design often, so that you come up with a large diversity of different solutions, and then you have some sort of a selection mechanism that weeds out the bad solutions, those that didn't work, and gives more resources and feeds those solutions that worked well. In a complex context, we really need to be aware of the risks that we are taking. We need to anticipate and not go into situations that will turn out disastrous for us. Whereas in a complicated context, your goal is to be right, and if you're right, then you're right. And that's sufficient, because you actually can be correct, although it might not be a good idea in complicated contexts either to um, uh, put yourself into a situation where you really have to be right or else, as we spoke about in the when we talked about convexity in the previous section. And we need this uh, evolutionary trial and error way of working. It usually needs this stepwise iteration that was also brought up in the quote about Lindblom's incrementalism that I told earlier. Whereas in a complicated context, what we can do is actually do these long-term plans and expect things to work according to those plans. So whereas in a complex system or a complex situation, what we need to do is we need to figure out where we are and where we can move next. And because if we come up with a goal far away in the future and um, try to achieve that goal, it might be that once we have taken 2 steps towards the goal in the path that we thought that would lead us to the goal, the goal has actually shifted from being not really something where we want to go anymore. And there might be other opportunities and other goals that we would actually want to take. So in a complex context, you would want to just stop, uh, probe what you're doing, probe the environment, and then go where is the next right place for you.